Alrighty, welcome back online learners. Today we're going to be taking a look at dimensional analysis. Dimensional analysis is going to be a two-part lesson as there is a lot involved in dimensional analysis. I have heard from Mrs. Denowden explicitly that you guys have been taught this in physics, so this should hopefully be review. We're just going to take it a step further and do things in a little bit more depth than you would have in physics. So today's learning objective is to be able to convert between various units using dimensional analysis. Apparently I cut off the rest of the word. So this is in your note packet, so go ahead and open up your note packet. I know for the general chemistry students it is on page 9. I'm sorry, honors chem students, I'm not sure what page this is on in your notebook. So if we get started here, looking at these three images, if my slide will change, there we go. Looking at these three images, you see an 80 kilometers per hour sign, a kangaroo next 10 kilometers, and a maximum speed of 50 kilometers per hour. I want you to think, do you know what kilometers mean? Do you know if you were driving a car, how fast could you actually go if it was 80 kilometers per hour? Would you be speeding? Would you not be speeding? Yeah, you're not going to do dimensional analysis in your car, but it's good to know how these different units relate and how things can be transferred from one form of unit to the next. So what dimensional analysis is it's a method of converting units of measurement in order to correctly solve problems. So dimensional analysis is literally turning one unit into a different unit. So going from seconds to hours, going from miles to kilometers, going from grams to milligrams, or centimeters to millimeters, all of which we're going to do in chemistry. We're going to use this strategy later on, especially in second semester when we look at really hardcore math and stoichiometry and we convert something called mole to something called Avogadro's number. So dimensional analysis is just a method of converting units of measurement to help solve problems. Okay, and when we're using dimensional analysis, we use what are called conversion factors to solve the problems. A conversion factor is a ratio of units which you multiply by the value you want to convert. And that sounds pretty confusing, so I'm not going to have you write this definition down because it's already written down, I think, in your notes anyway. I'm going to show you some possible examples of a conversion factor. So let's make my screen bigger here. Okay, an example of a possible conversion factor, can you see this? Perfect. Would be that there are 4 cups per every 2 pints. Okay, there's 4 cups for every 2 pints. You can also write this as there's 2 pints in every 4 cups. So thinking of conversion factors in baking. Other conversion factors, there's 60 seconds per 1 minute. Okay. There's 5,280 feet per 1 mile, and vice versa. These are all examples of conversion factors. You will need to memorize some of these. I will be sharing with you a list of the ones you need to know and the ones I'm going to give you for the test. So make sure you check that out on Canvas so you know what you need to know for the test and what I'm going to provide you with. Alrighty, so let's keep going here. So let's go over some examples. Not yet. Sorry. My examples page is for the examples of conversion factors that I just went over. So canceling units is also very important. We talked about this briefly when we talked about density, of how do we cancel grams on the top and grams on the bottom. Units are going to be canceled if you have a unit on the top of your conversion factor, and on the bottom you can cancel it. Okay, that'll make more sense when we go over this example problem here. So how many quarters are in a dollar? Let's do that together here. How many quarters are in a dollar? How many quarters are in a dollar? What I'm going to have you do for every single one of these problems, I want you to underline what is given, and I want you to circle what you want. Okay, so I want you to take a moment and go ahead and underline what we're given in that example, and I want you to circle what we're looking for. This might be a little tricky to figure out at first, so we're going to underline what we're given. We're given $1. You can't see the blue, so I'm going to get a different color. We're going to underline the dollar because we're told that we're given $1, and we're looking for quarters. Okay? When solving problems using dimensional analysis, it's going to be important to always start with the underline. You're going to start here. You're going to start with what you are given. And I know it's really easy for you to figure out this problem in your head, but it's going to be really important to start using this process now so that come future when the problems get a lot harder, you know how to solve them. Okay, so we're going to start with $1. We're going to put it on the top of our conversion factor. Okay, we're just going to put it at the top. Okay, like this. What's a possible conversion factor that tells us between quarters and dollars? Good, there's 4 quarters and $1. Okay, so what we need to do now is we have dollars on top and we don't want dollars anymore. So we need to get rid of dollars. In order to get rid of dollars, we're going to put dollars on the bottom because like I just told you, in order to cancel units, you have to have one thing on the top and one thing on the bottom. And we're going to plug in our conversion factor here. So we have $1 is equal to 4 quarters. So now we have dollars on the bottom, we have dollars on the top, we can cancel out the dollars. Are we left with what we want, the circle? We're left with quarters, so this is done. Now what you're going to do is just multiply across the top. So 1 times 4 equals 4 over 1, which is 4 quarters. Oh, it's cut off a little bit, but it says quarters. Notice I set everything up in these little brackets. What these brackets mean, you could also write it like this. $1 times 4 quarters over $1. However, I'm going to encourage you to use this strategy up top because it helps you in the future. Because once you cross this line, you don't look back at it. Okay, that'll make more sense as we keep doing more example problems. I have one more I want to go through with you, so let me take a moment to erase my whiteboard. Alrighty, this next problem I want to go over is how many seconds are in a day. So when we start this problem, we're going to do the same as we did before. We're going to underline what we were given and circle what we want. So we were given a day, and we're looking for seconds. Can you think of any conversion factors that goes right from seconds to day? You might know how many seconds are in a day, but you might need to use some smaller conversion factors to get there. So let's write what we know first. We know that one day has 24 hours. Okay, so we've gotten from days to hours. We know that 1 hour has 60 minutes. And we know that 1 minute has 60 seconds. So we need to use several different conversion factors to solve this problem. So I'm going to show you how you would plug this in to solve it. So we're going to start with 1 day. Remember, we always start with what we're given. So we're going to use this conversion factor first, and since we have days on top, I of course need to put a day on the bottom. So 1 day is, 24 hours. Okay, and I can cancel out days. Notice how I'm writing my units every time. That's going to be super important, so make sure you start that habit now. So now I'm at hours. I have hours on top, so I need hours at the bottom. And I have 1 hour is equal to 60 minutes. Again, cancel out my hours. Let's shift it this way a little bit. I know that 1 minute is 60 seconds. I can cancel out my minute. And notice I'm left with my seconds. Okay, I'm left with seconds, so that's what I want. So I'm going to multiply all the way across. 1 times 24 times 60 times 60. So go ahead and plug that into your calculator real quick while I plug it into mine. Okay, I got 86,400 seconds in 1 day. Let's double check the math there. Good. Okay, that many seconds in 1 day. So this is going to be the start of our dimensional analysis work. This is going to be a lot to start with, okay? This isn't supposed to be easy right away. You are going to have some homework to do, so make sure you check that out and get started on your homework. And of course, let me know if you have any questions. I've also posted some supplemental videos that go over this further with extra example problems, so make sure you check that out if you are confused. Thank you.